In calculating oxidation states of polyatomic ions, the oxidation state is always equal to the charge of the polyatomic ion. Okay, the sum of the individual oxidation states will always be equal to the charge of the polyatomic ion. So now let's see what this means. Now we know that for the compounds, we always equated everything to 0 for the neutral compounds. But now, instead of equating everything to 0, we are going to equate everything to the charge that we have there. So let's see the first example. We don't know that of nitrogen, so we are going to use X to represent that. Plus 2 times oxygen is minus 2. And everything should be equal to minus 1. Because there's a minus sign here. So this time around, instead of it being equal to 0, it is equal to minus 1. Now, X plus minus 4 is equal to minus 1. Okay? Minus 4 because 2 times minus 2 will give us minus 4. Then we send the minus 4 across the equal sign. So we're going to have X is equal to, when minus crosses the equal sign, it becomes a plus. 4 plus 4 minus 1. And then 4 minus 1 is equal to 3. So that means nitrogen's oxidation state over here is plus 3. Okay, we equated everything to minus 1. Now let's see that of the hydroxide. We have only one oxygen atom here. So we have 1 times negative 2. We don't know that of hydrogen, so we're going to use X. And everything should be equal to negative 1. So 1 times minus 2 is minus 2. Plus X is equal to negative 1. When minus 2 crosses the equal sign, we're going to have X is equal to 2, because the minus 2 will become a plus 2. And then there was already minus 1 there. And that will give us X is equal to plus 1. So the oxidation state of hydrogen in hydroxide is plus 1. Remember, we always equate to the charge. Now let's see that of this tetraoxosulfate here. We don't know that of sulfur, so we're going to use X. Oxygen is 4 times minus 2. And all this will be equal to the total charge, which is equal to minus 2. X plus 4 times minus 2 will give us minus 8. And everything is also equal to minus 2. When you send minus 8 across the equal sign, it becomes a plus. So we're going to have X is equal to plus 8 minus 2. And then we are going to have our final answer. 8 take away 2 is going to be plus 6. So the oxidation state, or the oxidation number of sulfur in this equation, is plus 6.